bandwidth they needed. Based on that, the capacity being designed take a lot number of access points, make them operate at the lowest power level possible, so that lot number of clients can be connected, the speed will be good, and they will be able to receive a guaranteed bandwidth. Right? Now, when you talk about your channel availability, like I told you, we share a common airspace with many other devices which tend to create interference to legitimate wireless traffic, and those are called a non-802.11 devices, right? Such as your microwaves, video security cameras, Bluetooth devices, cordless phones, and gaming boxes such as PlayStation or Xbox, right? These devices tend to create an interference to a legitimate wireless traffic, right? So, to deal with that, right, Aruba has provided us something called spectrum analyzer, right? Where in which using the spectrum analyzer, it will be your access point will be configured as a spectrum analyzer, where it will be able to detect these sources of interferences into your production network, and it will be able to show you with this intuitive dashboards issues that you have in your production network, what kind of interferences that you have in your production network. All of that will be able to find out using your spectrum analyzer, right? Now, like I told you, these are the common sources of interferences, such as your video security cameras, Bluetooth devices, cordless phones, microwaves, right? These are common devices called as non-802.11 devices, right? And also misconfigured access points. What do you mean by why is this APs written in this common source of interference? Because your access point may also be configured wrongly, right? You may configure certain channels that are overlapping with each other, right? That may cause something called co-channel interference, right? This can also be detected by a spectrum analyzer, right? So this is a typical screenshot taken from a spectrum analyzer, right? This is the old screenshot, right, from your spectrum analyzer. However, when you are working with your own spectrum analyzer in your own production network, you will see your dashboards have become much more intuitive, and it gives much more information with respect to what kind of existing non-802.11 devices you have in your production network. Next is your antenna technologies. Right? Typically, you've got two types of antennas. One is omnidirectional antenna, and the other is directional antenna. When you talk about your omnidirectional antenna, your radio waves will be propagating in a circular fashion, right? Your antenna, your radio waves will be propagating in a circular fashion. However, when you talk about your directional antenna, right, you are trying to focus your radio waves on a particular degree or a particular angle. Such as, let's assume there are certain bunch of clients that are sitting here, access points are situated here. So you're trying to focus your your radio wave at a particular degree or a particular angle, right? That is nothing but your directional angle. However, you need to understand that the way in which your radio wave, the energy of your radio wave, the way it traverses, right, it by the nature itself is in a circular fashion, right? So when you talk about your light, right, so when you take a torch, right, you've got this torch, and this is your button, so once you click on it, you can see that your light, for certain distance, right, it travels in a straight fashion before it loses energy and it's spread across here and there, right? That is how the energy light works, right? It is quite focused the way in which it directs its energy. However, your radio waves is not like that. Even though if you are using a directional antenna to design your radio waves to move to a particular degree or particular angle, you need to understand that the way in which it traverses is in a circular fashion, right? So there will be certain radio waves which will be completely unused, but that is okay. We don't have to worry about it. That's the nature itself. We can't do anything else, right? Next is your reading your AP radiation pattern, right? So this is just a screenshot taken of your, radiation pattern of an access point from the top view, right? So looking at the screenshot by itself makes no sense unless you put this in a software and you are able to see how the radio wave traverses horizontally and vertically, and what is the kind of footprint of your particular WLAN. Right? But that is not the importance of this slide. The importance of this slide is from your ACMA exam, where you will definitely be asked a question. What is the AP radiation pattern of a horizontal plane, right? So it is also called azimuth, right? And it is also called top view. Right? So it's very important from your ACMA exam perspective. Right? So you will definitely get a question either from this or from this. One question you will get where it will ask, this is a reading of AP radiation pattern, right? Looking at an AP radiation pattern. They will not give you a diagram, right? They'll just ask you a question, what is the another name of that, right? Of a horizontal plane, right? It is also called azimuth. It is also called top view, right? Now this is a vertical plane, also called elevation, also called side view. Now, this is apparently the side view of an AP radiation pattern. Now, we will not be able to differentiate the screenshot from this to this, from your top view to side view, because we are looking at it from a 2D perspective. However, when we put it in a 4D software, then we'll be able to see how your signals are traversing horizontally, vertically, what is the kind of footprint. That is all we'll be able to see. But that is not important. For now, the most important thing is from the exam perspective, you will be definitely asked, what is the AP radiation pattern of your vertical plane also called? Right? It's also called elevation, right? Side. Right? Next is your passive E-plane antenna gain. Right? This is just a process in which your access point used to shape the coverage area of a signal. Right? If you want to stretch your signal horizontally, right? If you want to stretch its WLAN signal vertically, right? It uses the concept of antenna gain. Right? If you want to stretch your WLAN signal horizontally, then you need to configure high gain omni, where it stretches its WLAN signal horizontally. Right? And if you want to stretch your WLAN signal vertically, right? That is nothing but you're setting up your access point in a low gain. Right, so based on your production network requirement, where do you want to stretch it, how do you want to shape the WLAN signals, based on that you'll be able to do that using this antenna gain on your access point. Right, so this is a screenshot taken of a top view, also called as horizontal plane. Right, so you will definitely be asked a question, guys, either from your horizontal plane or from your vertical plane. Horizontal plane is also called azimuth. It is also called top view, right? Your vertical plane is also called elevation. It is also called side, right? And these are the different mounting options, right? You can mount it on your ceiling, you can mount it on your side wall, you can mount it on the floor as well if there is no space on the side wall, or if there is no place, or it is physically not possible to mount it on the top or on the side. Typical example is your stadiums, right? Then you can also mount it on your floors as well. Next is your single input and single output. Right? This is a legacy technique which was used by your IEEE 802.11b A, G and B standards in order to send the data between your access points. What is this technique? At any given point of time, right, there will be only one single antenna used to send the data from source to destination. Right? So from your access point, it will use only one antenna at any given point of time to send the data. Let us assume what is the data that is sending. It is sending the data hello. Right? On your antenna, it has got these two integrated antennas. And it is receiving this hello message from your access point on these two antennas with different signal strength. Right? It is receiving this hello with two signal strength on antenna 2 This is in this antenna 1, and in this antenna 2, it is receiving the hello message with the best signal. Now, using the single input and single output, it would use this antenna to reply back to that access point. Right? So this is a legacy technique where you're not using all your antennas at the same time. At any given point of time, you're using only one single antenna, and these are the single, legacy techniques of your wireless devices. And one more issue that you had in the previous generation of your wireless devices is multipath propagation scenario, where whenever your access point is sending any data, that is, assume it is sending the data hello, right? By the time, there is a possibility that the data might go directly to the client device, right? But there is also a possibility it may hit on the floor, then reach to the client. It may hit on the ceiling, then reach to the client. It may hit on the back wall of an access point, then reach to the client. It may hit on the back wall of your client device, then it reach to the client, right? So there is a possibility for that as well. Now, in that scenario, what used to happen is your client devices used to get multiple frames, multiple times, and which lead to issues, very typical issues where they're not able to process the data. They're not able to process the data. And at any given point of time, they could use only one single antenna, right? So the duplications of the data used to happen. And these are all legacy issues that we used to observe in the previous generations of your wireless devices. However, in the next generation, the new standards, which is your 802.11n and 802.11 AC standards, we have something called multi-input and multi-output, right? So what is this multi-input and multi-output? Using this, you will be able to use multiple antennas at the same time to send the data between your clients and your devices, right? And in your 802.11n and AC standard, I also told you there's something called spatial stream. What is the spatial stream? Now, if you look at the information of a spatial stream on Google, you will find the information or the explanation is something like this. Individual coded data into the open airspace, as simple as that. Individual coded data being sent into the open airspace. What do you mean by that? Individual coded data being sent into the open airspace. Meaning that using multi-input and multi-output, where between your access point and your clients, the new generation devices which uses the standard, they uses multi-input and multi-output, where they use multiple antennas at the same time, where using spatial streams. What is spatial streams? Sending individual coded data into the airspace. If you want to break it down, it is as simple as this. Hello, how are you doing today? Individual coded data being sent into the open airspace means that you are able to send multiple data, sequential data you are able to send into the open airspace using multiple antennas at the same time. That is why you can see the significant jump of speed, which was in Mbps, right? Between 50 Mbps to you were able to jump. In your 802.11n, you were able to jump up to 450 Mbps, right? Now, like I told you, in 802.11n, each antenna will get its speed up to 150 Mbps, right? Typically, these access points comes with two integrated antennas. That is why you get an aggregate of 300 Mbps, right? If you got if you got two antennas, you get 300 Mbps. If you've got three antennas, you get 450 Mbps, right? So this is your multiple input and multiple output along with the spatial streams, where you're able to send sequential data, multiple different data sent in a sequential fashion into the open airspace using multiple antennas, using multi-input and multi-output, right? Now when you talk about your 802.11 AC, your AC had two waves, wave 1, right, and wave 2. The wave 1 can get you speeds up to 3.5 Gbps and wave 2 can get you up to 6.93 Gbps. Because in wave 1, we are using MIMO and spatial stream. However, in wave 2, we have something called multi-user MIMO and spatial stream. Now, what is your multi-user MIMO? Now, when you talk about this process is being carried out between one access point and one client. Right? This is one single client and this is one single access point. And between this, we are using this multi-input and multi-output. We're using spatial streams, and the way in which the wireless communication is happening, it is sophisticated. It is much more significantly sophisticated compared to previous generations. Agreed. But this is just between one access point and one client. Multi-user MIMO is having this kind of setup with multiple users, meaning that you will have individual spatial streams with multiple users using multiple antennas from the same access point. Right? The same concept of MIMO and spatial stream between one client, you take it a one step further with multiple users. This concept of multi-user MIMO was introduced in your 802.11 AC wave 2, which you were able to support up to only 4 clients. However, in your 802.11 AX standard, which was released in 2018, this is the standard which it will use all the time. With how many users it has, it will be able to use multi-user MIMO. It will be able to send individual coded data. It will be able to send individual streams of coded data with different clients, with different users, with different antennas at the same time. Right? So your AX standard, IEEE 802.11 AX standard, which was released in 2018, like the reason that I told you by far it is the best standard is because of this. You'll be needing less amount of access points to get you gigabits of speed with your multiple clients because it uses multi-user MIMO along with your spatial stream. Okay, can you answer this question? What technology enables APs to send different users' data along separate spatial streams?
What APs to send different users' data?
Awesome, right? It is your multi-user MIMO. Okay. Answer this question, please.
What of you?
Right, so that those azimuth and your elevation, guys, it's a very important question. You will definitely be asked a question in the exam regarding that. Right, so don't forget it. The next is your power levels. Right, so this is very important. Your RF transmit power. So based on your power level only, you will be able to understand what will be the coverage area of the signal. Right, this is your access point. You'll be able to understand what will be the coverage area of the signal, how far the signals will travel, right, and what will be the total speeds that the client will be getting from the access point. Right, so when you talk about your power levels, right, we calculate our power levels in decibels relative to milliwatts. Right, typically, when you talk about your weight, we can either communicate in kgs or we can communicate in pounds. And 1 kg is equal to 2.2 pounds. Right? Similar to that, when you talk about your wireless network, we communicate verbally on the power levels. Right? We work with your decibel relative to milliwatt. Right? Because your decibel relative to milliwatt uses something called a logarithmic scale. Your milliwatt uses a linear scale. If you try to work with your milliwatt linear scale, you'll be getting this complicated value. Let's take an example. Right? Let us assume this is an access point. right? And you've got this client which is connected here, and at certain distance, let us assume at a distance x, it is getting the RSSI value as 1, right? This is the value that it's getting. What is RSSI? This is a very fancy word for signal strength. RSI stands for Received Signal Strength Indicator, right? So at a distance x, the RSSI value for this client device is y. Let us assume if the distance is doubled, right? The distance is doubled. Do you think it will be half? By the logic, yes. If it is increasing, the distance is increasing twice, then my speed should reduce, my signal should reduce in a half, right? That is basic maths. However, this is only true when you're talking about using a linear scale. You talk about a linear scale, you get these complicated numbers. But we don't use that. We use a logarithmic scale. Logarithmic scale are much more easier to understand, much more easier to work with, much more easier to communicate, right? So we do not use linear scale, we use decibel relative to milliwatt scale, which is your logarithmic scale. However, if you're really good at maths, you really want to convert your decibel relative to milliwatt value to your milliwatt scale, then this is the formula 10 log 10 signal power by 1 milliwatt. And this is the formula that you can choose, right? Not however you won't be hitting it. Right? Next is working with your power levels, right? How do I increase and decrease my power levels? Right? So whenever you are increasing or decreasing your power levels, you need to understand that you work with the concept of 3s and 10s. Right? You only work with the concept of 3s and 10s when you're increasing or you're decreasing your power level. So let's take an example. Right? This is what now you are a network engineer, you are an engineer, you are working on an access point. Your requirement is that on that access point, I'm taking this as a base number. In this example, I'm taking this as a base number. Right? Now from this base number, my requirement is that I want to increase my power. Right? So it is situated in the canteen, in the central location of the canteen, and my requirement is that it is not reaching to all the corners of the location, all the corners of that physical location. I want my access point to increase the power level so that the signals will reach to farther distances. Now, from this base number, if I want to increase my power level, what I should do? I should be using the concept of 3s or 10s. Either I can do plus 3 dBm, right? 23 dBm. The 20 dBm, it goes to 23. What will be the actual effect on your power level? It moves from 100 milliwatts to 200 milliwatts. So power will be doubled if you do plus 3 dBm. If I do one more plus 3 dBm, my requirement was not fulfilled. I still feel that the corners are not reaching, the corners are not properly getting the WLANs. Then what I'll do again a plus 3 dBm. And it goes from 23 dBm to 26 dBm. What happens to my actual power level? It increases twice. From 200 milliwatts, it goes to 400 milliwatts. Right? Still, I want to still increase my power level. What I can do plus 3. Right? It goes from 26 to 29 dBm. What happens to my actual power level? It doubles. Right? From 400, it goes to 800 plus. I can do either plus 3s, go in a step-by-step fashion, right? In a small fashion, or I can do a plus 10. Right? Directly from plus 20, I can do plus 10 dBm, which gets me 30 dBm. Right? Where my power level will be increasing 10 times. Right? From 100 milliwatts, we go to 1 watt or 1000 watt. Right? If I want to reduce my power level, right? what I will do, I'll do a minus 3 dBm. From 20, I'll take it down to 17 dBm. What happens to my actual power level? It reduces in half. I want to reduce more. Let's do minus 3 again. It goes from minus 17 to 14. What happens to my actual power level? It reduces half. Let's do one more time, minus 3 dBm, right, from 14 to 11 dBm. What happens to my actual power level? It reduces in half, from 25 milliwatts to 12.5, right? Or I can do minus 3, I can keep doing minus 3 and try and reach to the desired point where I'm looking at. Or from your 20, I can do a minus 10, right? From 20 dBm, I can get it to 10 dBm. I'm reducing it 10 times. And what happens to my power level? It reduces 10 times, right? From 100 milliwatts to 10 milliwatts. So why are we talking about this? We are talking about this because from the administration perspective, when you are increasing or decreasing your power level on your access point, you will be doing it in either 3s or 10s. You will be increasing or decreasing with the logic of 3s and 10s only. You cannot use 2, 1, 7, 10, 11. You won't be using these numbers. You can only increase your power level of your access point, or you can only decrease the power level of your access point using the concept of 3s and 10s, right? Nothing else, right? Next is your signal to noise ratio. Now what is this? SNR is used to evaluate the quality of the signal, right? Now, what is this? Like I told you, SNR is used to evaluate the quality of the signal, as simple as that. But there is a way in which we can calculate your signal to noise ratio. How do we calculate difference between your noise floor and RSSI, right? Now we have something called noise floor. What is this noise floor? This is not the interference. This is the wireless, this is the status of the airspace or the noise of the airspace that is present of this planet Earth. Right? This is the agreed upon value, minus 95. Some vendors say minus 90, some vendors say minus 95. Most of the vendors say minus 95. But this is the agreed upon value that this is the noise floor of the planet Earth. Right? And this is the value that is agreed upon. Now what is SNR? SNR, like I told you, it is used to evaluate the quality of signal. How do we do that? By using this formula. Difference between the noise floor and the RSS. Now we have this value, noise floor, we need to get this value, RSS. We'll try to get that. Let's take an example. Let me have an access point, right? And this is your client. It's connected at certain distance, 2x, and at 2x value, it is getting the RSSI value as minus 75. Right? Now, what is SNR? SNR is used to evaluate the quality of your signal. Right? How am I able to evaluate? By using this formula. What is the difference? How do I know the SNR value? Difference between the noise floor and the RSSI. What is the difference between the noise floor and the RSSI? Minus 95 dBm, minus 75 dBm, plus 20. Now I have got this value. What should I do with this value? Every vendor, Aruba, has also given certain recommended values based on your setup. If you have got a coverage-based design, or if you have got a capacity-based design, the SNR value must be plus 35 or more. More the better, but minimum it should be plus 35. Right? If you have a coverage-based design, it should be minimum plus 25. More the better. It can be 100, it can be 1000, doesn't matter. But minimum it should be plus 25 for you to have a good coverage based design. And if you want to have a good capacity based design, you should get a SNR value of minimum plus 30. Now looking at this value plus 20, do you think is it a good value? Is it a good coverage based design value? Is it a capacity based design value? It's falling into nothing. Right? So with this, you will be able to, again, this is very helpful from the administration perspective. You will be able to understand what is the SNR value. Is my clients, they are connected, are they connected in a healthy fashion? You will be able to signify that by getting this SNR value. And don't worry, you don't have to calculate all of this. You will be able to get all that information from your Mobility Master dashboard. Right? So what do you do in this such case? So we have got a client which is getting a very bad SNR value. You can see that he is connected at a distance twice what is recommended. We'll tell him to reduce. Go and sit at a distance X. Right? Now the value will change to minus 75 to minus 55. Now what will be the difference between, what will be the SNR value now? Minus 95, minus 55, what is the difference between them? Plus 40. Right? So which is a very good SNR value for both coverage based design and a capacity based design as well. Right? This is your EIRP, right? This stands for equivalent isotropic radiated power. This is only used for your outdoor access point. Please understand, this is not used for your indoor access point. This is only used for your outdoor access point. Right? This is the total value which is need to be calculated for your outdoor access point. Because when you talk about your regulatory body, TRAI, ETSI, FCC, they all have given certain recommended values for your outdoor access points. It is around 36 dBm. It should not cross more than that. This value changes with time, but approximately it is around 36 dBm. But that your outdoor access point should not cross more than this value. If it crosses that, then you can be criminally charged because you are actually breaking a law from the TRAI or FCC or ETSI. So how do you calculate that? You calculate that by understanding what is the power level that you have configured on your actual access point, and from that access point you will be connecting your cable towards your external antenna. Right? Your external antenna again will have its own power level to shape the coverage area of the signal. Right? You can push your WLAN signals in this fashion, or you can push your WLAN signals in this fashion. So whatever that you want to do, that requires power, and that power is 70. The power level that you have configured on your access point, it is 20 dBm. Right? 20 plus 17, right? It is coming around 20, 30, 7 dBm, 37 dBm, and minus 3 dBm. Right? So this the signal that it goes from your access point to your external antenna. This cable will create some kind of resistance, right? So that it does not, if it doesn't create a resistance, if it gets a full flow of the traffic, your external antenna will not be able to handle that kind of amount of traffic. Right? So that is why there will be certain cable connector resistance. That will be a loss in that. So there will be minus 3 dB loss. So the total value comes around 27 dBm. Right? It will come around 27 dBm. So this is a type of mistake actually. It is 10 dBm. And 10 dBm power level is being used to shape the coverage area of your WLAN signals on your external antenna. 20 dBm is being used for your actual access point, and minus 3 dB on your actual cable connector. So total value is coming around 27 dB. Right? This should be the value. The value should be well around less than the value given by your regulatory body, which is around 36 dB. Right? Next is your WLAN mobility. Right? In this, we have got this BSS. Like I told you, BSS is a logical network created by an access point where it is connected to your clients. BSS ID is the unique identification of an access point, typically its MAC address. SSID is the name of the WLAN which is propagated. Just employee.
This basic service setting.
Right? Now again, this is one BSS, one logical network created by an access point where it is connected to its clients, right? BSS ID is a unique identification of an access point, typically its MAC address. SSID is the name of the WLAN that it is propagating. Now this is one BSS, right? This is one BSS, this is one BSS. If they both are propagating the same WLAN, then this becomes one big logical network called ESS, called Extended Service Set, and this becomes ESSIDs, Extended Service Set IDs, right? And next is your mobility devices. First is your stationary device, which does not move, which is camped at a certain location all the time, typically your Xerox machine or printer or scanner. Next is your somewhat mobile devices, typically the one with which we can roam, but we don't tend to roam with those devices, such as your laptops. And next is your highly mobile devices, which is your tablets and your phones, right? And this is the client mobility. Like I told you, this is one BSS, this is one BSS, one logical network, one logical network. This is a unique identification of this access point. This is unique identification of this access point. This is the name of the WLAN, SSID guest, SSID guest. And these two having the same BSS, having one same logical network, becomes a ESS, Extended Service Set, right? If these two access points are propagating the same WLANs, right, these two logical networks becomes one logical network, which is your Extended Service Set. And this is very, very important from your roaming perspective, right? So whenever your client moves from one access point to another access point, this is the location where your client is going to move. It is going to come at a point where it will know that yes, I'm going to a new wireless network where this access point can provide me a much better service, because the signals are just increasing and increasing from where I'm going, and the signals are decreasing and decreasing from the access point that I'm connected. Right? So this is the most important point in your wireless network, where the coverage overlap you must provide. Whenever you're setting up your wireless network, you always need to ensure that you are setting up these coverage overlap from one access point to another access point. Obviously, there will be a different channels, right? This will be channel 1, this will be channel 6. However, physically, their WLAN signals must overlap with each other, so that the clients, whenever they are moving from one access point to another access point, they will be able to seamlessly roam without any disconnections, right? And this is the point. In order to provide them the seamless roaming, right? From one access point to another access point, seamless function. Okay. Can you answer the last question? Laptop, which type of mobile device?
Laptops.
This is somewhat mobile. Laptops are So laptops for us, it is highly mobile device, but for it is somewhat a nomadic device. Right. So with this, we have completed the first module of the day. I know it is a very, very large module, guys, but those were the fundamentals. And I am fasting, so I am going in a way that it doesn't dry up my throat. So please cooperate with me. I'm trying the best I can to convey, and in a way that I don't drain myself. Right? So I'm taking little breaks here and there, talk slow, so that I'm able to maintain the energy to come to talk for a long time. Right? So thank you for cooperating. And yes, this is a very large, very big module. First module is obviously